I'm Jack. You said what? I'm Jack's brother. The short one.
A momentary laugh and gap and like forgot where I was. Now I'm okay. Don't be concerned. I can rally. The day started off strangely when I found out that we teachers only had to go to one of the two masses, like either today or tomorrow. Since I was teaching all the way through today, I thought, what more fun to go like during the mass this morning than to go on a massive quick 10K run and try to get back in the shower and get to class. So that was the first out of the gate, run, back in the shower. So then it meant the whole day was kind of very strange. Okay, that's there. I got almost everything done. Now I just need a quick share. While I'm doing this, can you guys take out questions, homeworks, all that, notes, and those few cutesy things? It's really helpful to me if you guys have that out as soon as possible, considering I'm like running around like a madman trying to get everything going. It's actually ironic that the people at home can see the stuff on my screen, but you can't yet because I'm not click shared. Weird, huh? And that's up. Okay, we're good. Oh my gosh, I have a gift to myself. Yay me. Matthew, guess what? There is already a video up from 2 years ago. Actually, it's longer than that. I'll still record this class, but if you want the one that's a little bit more concise and condensed, it's up there. So if you missed something, this is me walking through the notes, and you can find it there. Got it? Whew, because he has to leave early. Okay, that's there, done. Close that. Close that. Close this. I need to free up some system resources. Okay, next bit. While you guys are kind of finishing that whole getting ready thing, I'm going to take attendance because I'm supposed to do that and be like a, I don't know, responsible teacher person. Let's see. We're all here. What are we running? Everyone's here? Okay, we're going to start with this and then go back to homework questions in a bit here, because I want to get through and make sure you have a very, very solid foundation of this. So I'm not saying this is going to be easy. If it was, well, we call it accelerated algebra 1. Kidding. Sorry, sophomores. But it's going to just take a little bit of persistence, diligence, and just trying something. So my request to all of you is if this starts to get a little challenging, back up and try something. You got some pretty good heads on your shoulders and some ability to look things up. Your book itself has examples in the chapter right before it. We have some more examples here. I've recorded myself on this part, like walking through some more examples. So if you need to see a few more, this is there. This is located in your content library under today. Like if there's ever videos or things I want to put on that are a little bit more than we do in class, you're going to see them appear under class notes. But this is one that's from a couple of years ago. You can tell because it has Windows 8.1 down there. But it's just like my set of, I know some of you may want to see a few more examples of some of the different types of questions that we're going to get. Word problems are one of those things that, think of this as like that first time you rode a bike. It's something you have to actively think about until that moment that it all clicks, and then you don't have to think about it ever again. because it will become very automatic. So you have to allow for the challenge. You have to basically allow yourself to fall off the bike a few times to kind of get the idea of it. Not everything is going to be just as simple as, in this case, do this, in this case, do this, because there is a little bit of, you've got a lot of things you can try, and you start becoming very experienced with what the optimal sets are. So I'm going to try to break this down as simple as I can, but I know there's still going to be some variance for different scenarios that come up. Let's start. I'm just going to pour out number one and start walking through a couple of ways to think about this. To start, take about 20 seconds and read the problem to yourself. Go. How fast is the other car traveling? The problem doesn't say that. Wouldn't it be nice if the problem said that and then there would be fewer words in the problem?
Yes.
That's one of those tricky little pieces of information that's actually in the problem. So we're going to denote that down. One car goes 45 miles per hour, and the other car is 55 miles per hour. You don't have to do this, but I've seen a technique where if you use a piece of information in a word problem and you want to kind of ignore it, you can sometimes people just cross out the bit that you used, because that's done. And how many hours will the cars pass each other? I think of this like we're taking a snapshot, a picture, a video, something. We're taking a picture at the start of this whole scenario, and then we're taking a picture at the moment the cars pass each other. And no matter what car you are, is that the same amount of time? The cars start 250 miles an hour apart. They drive, and at some point they pass each other. Will the people in the different cars experience the same length of time? Do not get all relativity on me, because they actually don't. That's a whole other conversation for physics later. But yes, for our purposes, we're going to say they experience the same amount of time. I'm going to say let those words that appear in a word problem somewhere, let t equal the number of hours. And I'm keeping this one a little bit simple because it's consistent with the two cars. I don't need to go much more specific than that. T is the number of hours. Let's not go t equals time. I get that. Let's actually use a unit on it so you've got a kind of sense this is a total number of hours that happen. So next I'm going to draw a picture. We've got some information down. I'm going to draw the picture. We'll make this car A and car B and really boring about it. So here's A and here's B. That's not a consistent picture. There's B. And these cars go and they meet at some point. When I draw these pictures, I don't always draw it so that the arrows pop dead smack in the middle, because I want you to have the sense that maybe one went further than the other. Okay, at the top, how long is this orange line? What's
250 miles.
250 miles. Whenever we build equations, what we try to do is express the same idea in two different ways and set them equal to each other. So I have the entire length is 250 miles. The piece that car A travels before it hits should be something, and the piece that car B travels. So wouldn't it make sense that the length of this line segment plus the length of this side line segment equals the length of the whole thing?
Yes.
That's what we're going to be doing. So all that's left is to figure out how long this line segment is. Well, that's where this thing comes into play, because we don't know. What I do know is that the distance that car A travels, which I'll express as d sub A, is equal to the speed of car A times its time. In other words, this equation that I'm sure you have mentioned or heard before, distance is equal to, you can say it, rate times time. If you've never seen that before, then let's talk about the units themselves and why this actually makes perfect sense. Like let's say the rate is in feet per second. If I multiply feet per second times time, which is a number of seconds, I should end up with the number of feet. Especially sophomores, you're going to deal with this heavily in chemistry with what's called dimensional analysis. You haven't hit it up yet, but you will very soon. It's all about unit cancellation. Seconds is in the numerator here, and seconds over seconds cancel each other out, and I get feet. And I know that my units are working out well. And you don't necessarily have to be in chemistry right now to have the idea that if I have seconds over 1 and I multiply that, my seconds are going to cancel, and I get feet equals feet. Life is good. This also necessitates that rate and time be consistent units. So I'm not going to take a rate in miles per hour and multiply it by a number of seconds. I would have to do a little bit of converting, but that's later. So for now, everything is consistent. I've got miles and I have hours. If distance is equal to rate times time, we'll express this over here. The distance that car A goes is equal to the speed of car A. You get to pick which one that is. It really doesn't matter. Let's make it the 45, because that was the first. Times the time, t. And the distance that car B goes could be 55t. Which means that this little bit down here could be expressed as 45t. And this could be expressed as 55t. Now do you see how your equation is going to go? 45t plus 55t is 250. What is 45 plus 55? So we get t is 250 over 100, which is the same as 25 tenths, or 5 halves. But since we are actually talking about hours, we basically want to say 2.5 hours. The majority of times that we deal with actual math, we will not be converting back into to mixed numbers. We're going to keep them as improper fractions, but you probably wouldn't go and report to somebody that you've been traveling for 5 halves hours. They call you a math geek and never want to talk to you again. Okay, so that's a basic setup of one. You can also, if you want to, use a table. And I don't want to knock the table system. I kind of want to just throw it off to the side. That if I have a rate, a time, and a distance, and I say rate times time equals distance, then maybe car A's rate was the 45, car B's rate was the 55. They both traveled the same number of hours. The distance of one was 45t, the distance of the other is 55t, and the total of the two was 250. That is also more than fine as a way to show work. I tend to be very visual. I like diagrams. I like seeing things moving and seeing where they are. The table can be kind of dry, but it's up to you on what system you want to use. I just want to present this because sometimes, especially sophomores who may have been used to the tables, this works out really well. Won't be perfect every time, so let's talk about Carla and Dean. Carla begins biking south at 20 kilometers per hour at noon. There's probably no statement that you can make to your parents that causes them to sweat and like quiver in fear more than something starting that sounds like this. Try it. Say, when you go home, and you can do this, and if you want to record this and make this a video, I know you guys just got that acceptable use policy that says you probably shouldn't make memes of things that happen, but this is an exception because this would be fun. If I really did want to flip grid this, I'm not going to, but I would. Because that's going to be freaking hilarious. If you go home and say, hey, Mom, I need some help with this problem. Can you sit down with me? Okay, here it goes. Carla begins biking south at 20 kilometers per hour at noon. You will almost, I guarantee you, see the sweat beads down the faces of your parents because they will have horrific memories of being in high school and having to do these things. Guaranteed. Just ready for that. Or these moments of insecurity, like, Okay. You can do this, though. Carla begins biking south at 20 kilometers per hour at noon. We've got a couple things happening here. We actually have a starting time, which sometimes indicates that someone's going to start some other time. And in fact, Dean here starts later. But that sidebar. we know that Carla is going 20 kilometers per hour. So I'm not going to put that as a variable, but I am going to indicate that as some sort of rate. I'm actually going to adopt the table here just for a second to show you how this can help organize information. So we'll put Carla with C, and her rate is 20 kilometers per hour. I'm going to put kilometers per hour after the rate to indicate its units, but okay. And that's all I really know at this point. Then we have Dean. And it says Dean leaves from the same point 15 minutes later. Actually, right away, it has just defined a difference between the two of them. Put time in hours. So this is the first little trick of this. The question asks how long it's going to take Dean. I'm just going to ignore that for a second, and we'll put the variable as t for Carla's time. Should Dean be the same time? Should Dean be more time or less time? Definitely less time. We're leaving later. So it's less time. That means it's t minus something. We're chopping off hours. How many hours are we chopping off? A fourth. You see the 15-minute thing and how that's going to completely throw you, and you're going to be like, ah, you got caught by that. Don't let that catch you. That's like such an old trick in the book, like to say that everything's in hours and then I throw minutes at you. You can do that much. So t minus a fourth. I get a whole slew of students that kind of get confused on this because Dean leaves later. So if you don't think about it, you may add the 1/4, but you just have to stop and think, wait a minute, if I leave later for school, then I have to drive faster to get there because I have less time. This is the same idea. In fact, Dean is going to have to pedal faster to catch up to Carla because Dean left 15 minutes later. And then you keep reading the problem and realize it says Dean does bike at 24 kilometers per hour. So I'm giving you a very verbose explanation of why these numbers fall in the way they do. Yes?
So when we draw a chart, we don't have to.
You don't, because the chart just defined them for you. Like, it actually defines T is the number of hours that Carla went. You're good. What I really would want, and I'm not going to count you off if you don't do this, but it's good for organization, is to stick your units in there. That's it. That's just a really good practice. One of the advantages of a chart is it just gives you something to do. Like, it helps you plug your numbers in somewhere, and when you multiply them out, I know that rate times time is distance. I can do a little unit check, make sure that my units are matching. Kilometers per hour times number of hours should equal kilometers. And I can end up with 20t and 24 times t minus 4. So what am I going to do with those two? The distance that Carla travels and the distance that Dean travels. This is where a picture may actually help. Carla begins hiking south. Dean, 15 minutes later, begins biking south. What's true about those two distances?
At some point.
They're going to be what? Yeah, they're going to have to be equal to each other. That's the bit of this. If I'm biking in the same direction and chasing after somebody, I'm going to end up biking the same amount of distance as that person. So visually, this would be my setup. I would have just drawn the 20t and the 24t minus 1/4. And I'm okay if this was your work right here on the side. I still, at that point, would want you to put a let statement down because you put t in there and you didn't tell me what t meant. So I'm going to write this up above. Let t equal number of hours.
Would that be a different way?
Carla biked, and that would be a totally different, yes. That's why I'm kicking this off to the right a little bit. I'll actually put it off the page, so that's like another example. But that's a little bit about how my brain works. It kind of just sees the distances as products of two pieces, and then the pieces have to go together in a certain way. So whichever way you end up doing it, you end up with the same equation. 20t equals 24 times t minus 1/4. This is also where it's probably optimal to distribute the 24, so you can get rid of the 1/4. 20t is equal to 24t minus 6, or t would be equal to 3/2. double checking, triple checking, yep. Which is 1 hour and 1.5 hours. Then you have to go and actually say, did we answer what the question really wanted? T was the number of hours it takes Carla. This actually says the number of hours it takes Dean. So in my complete sentence answer, which, oh, no one caught me. I didn't even put on the first one, so I have to go back and write that in. We'll say it takes Dean. All right, what is 1.5 hours minus 15 minutes?
1 hour.
Yeah. You can write it how, as long as you're mathematically correct, I'm fine with however you write it. I would probably put 1 hour and 15 minutes just to be how people actually end up talking. Like in the first one, I should say it takes 2.5 hours. There, now I put my complete sentence answer. I'm not like contradicting myself. How are you doing? It's probably one of those that's easier when you see me doing it, and then you got to do it on your own, and you're going to have those moments of just blank. Remember, look back at your notes, have your notes next to you, or split screen, or something where you can see them when you're doing this. Okay, number 3. A person, we'll be gender neutral here, invests $6,000. Part of it at 5% and the rest at 7%. Annual interest is $372. How much did he invest at each rate? Okay, let's explain these because you're going to see a lot of this type of problem. You take $6,000. You're going to split it into 2 piles. One pile is going to get more money than the other. Why didn't you just put it all in the one with more money? Maybe that there are restrictions on the one with more money that you don't want to have. And this is actually a realistic scenario because sometimes you put things in higher interest rate accounts, but you actually can't touch it for 5 years. You have to ask yourself, am I okay letting this sit for 5 years and I can't do anything with it? Like you're not allowed to withdraw from it. So a person probably has to decide how much money they want. And then like maybe they say, well, I just want to make $372 off of this. So what's the split I have to do? Well, in any case, we're taking this $6,000 and we're splitting it into 2 pieces. So I'm going to kind of draw this out for you. 6,000, 2 pieces. Don't say it's 3,000 and 3,000. Then you're just kind of answering the question and you're done, which wouldn't necessarily be right. But we know that one piece is going to be a variable. The other piece is going to be the total minus that variable. I'm actually, you guys seem to favor the tables a little bit, so we'll do the table here. I'm going to put money, percent interest, and then I'll have interest money. So if the amount I put in one is a variable, and I need it to total 6,000, the other piece could be 6,000 minus that variable. And that makes sure that I've actually taken the 6,000 and split it into 2 pieces. If you like number lines, think of this as being 6,000. If this is x, then this should be 6,000 minus x, so that they would add back up to be the 6,000. Okay, let's not get caught up on this. What's 5% expressed as a decimal? 5, so we got 0.05 and 0.07, not 007. And then the interest I get off of them is the product of the two, 0.05x and 0.07 times 6,000 minus x. So the interest you get off one, which is this tiny amount, plus the interest you get off the other, is equal to your total interest. Shall we try to do this as much as possible without calculators?
Sure.
Build up your mental math. Okay. 0.05 x plus chop off 2 decimals and then just do 7 times 6. So that's a favorite number of the sophomores. Really? Sophomores don't get insulted by that?
What's wrong with that?
Nothing. I have no idea what you're talking about. Okay, then let's move things around. So I have 372 and 420, not 420. 48x is equal to 0.02. Oh, no, sorry, just 48 is equal to 0.02x. A couple ways to go about this. You could divide by 2 and then multiply by 100, which will probably be the easiest way to think about it. You can multiply both sides by 50, but I like divide by 2 and then multiply by 100. Do you ever realize that that's like a simple way to multiply by 50? Because 50 is the same as 100 divided by 2. And it's often easier just to divide something by 2 and then slide a decimal point. So 48 divided by 2 times 100. You get x is equal to 2400.
How did you do that again?
How did I get from there to x?
Yeah.
Okay, so what I'm actually going to do between this to this side is I'm going to divide both sides by 2, which gives me 24 is equal to 0.01x, and then multiply both sides by 100, which is going to give me 2400 is equal to x.
All right.
And then if 2400 is equal to x, then 6000 minus that gives me the other bit. So I can say he invested 2400 at 5% and $3,600 at 7%. Okay, last one of the notes, and then we'll go over some homework problems. Let's talk about food processing companies. This is a common type of problem that we've deemed a mixture problem. And a lot of these have been mixtures. Actually, every single one of them has been to an extent. But these kind of mixture problems, this is where tables are actually really helpful. The only other non-table way is to show a scale. I've done that before. But tables can be good. Because it keeps... Yes. Under content library, class notes, video, that's one. Okay, do you see where I am right now? And then also, I'm recording the class itself, like right now, on a Wii video over there. So as soon as I get that link sent, then I can send that to you by Google Chat or something. Yep. Bye-bye. Say bye, Matthew. Oh, he's gone. Okay, let's mix Parmesan and Romano, and that sounds fun. So Parm, Romano, and then mix. These kind of mixture problems tend to have 3 rows. Okay, then I need a rate to be in dollars per kilogram. That's what the rates of this are. So that tells me that my middle column is going to be number of kilograms. And my last column is going to be the dollar amount it is. Let me rewrite this. Dollars per kilogram and make it look better. Dollars per kilogram. So the Parmesan's rate in dollars per kilogram was $3.50. The Romano's rate was 5. And the mixture, actually we have one we want to do, that is 3.95. Can you take a minute and fill in the number of kilogram column. One of them is going to be a number, one's going to be a variable, and one's going to be based on the variables. We need 100 kilograms of the mixture. I'm going to put the X with the Parmesan. You can put it with Romano if you want. What's the other one? 100 minus X. Total minus the part. And I get 5 times 100 minus X. And if I multiply this, I get 395. So this last column becomes a total. The two should add up to the final. And that can generate your equation. The amount of money of Parmesan in it plus the amount of money in a Romano in it should equal to the total amount of monies for the whole thing. 3.5x plus 500 minus 5x is equal to 395. Or negative 1.5x is equal to negative 105. I am going to make life a little bit simpler on myself and multiply by a 10 and divide by a 5. And kill the negatives. Because if I multiply by a 10, it slides to decimal, which I can just pretend like there's no decimal there. And if I divide by a 5, I can get 3x is equal to, if you divide this by 5, it's 210. And then it's a little bit better mental math. It's like, oh, yeah, that's 70. Grafsky's like, I got that 5 minutes ago. And so it says they need 70 kilograms of parm and 30 kilograms of Romano. Yeah. Costco style. A fun place now that they have toilet paper. What was I do? Oh, I just want to make sure that the homework is correct on here. I'm 90% sure it is, but I don't like having homework listed down. Mrs. Manton loves putting homework at the bottom of these worksheets. I'm like, great, if we change it, then change it and everything. That can be bad. Let me check. Yeah, it's the same. Okay, let's take out homework questions. Are you all good on where to find your homework? And locate? And you can, I'll leave this up if you want to write it down, but it's on OneNote as well. Yeah.
What does it mean by all? Like, after the problems, it says like all.
It means not odds or not evens. So.
Oh, okay.
Sophomores will see that, and then I'll get at someone that says like, oh, I just did 9, 11, 15, and 19. I'm like, yeah, no. It's also worth noting that your textbook has 3 sections for problems, oral, written, and problems. Just be careful that you're in the right section. Like usually the scanned pages I put, I kind of try to indicate to you, here they are. But if you have the whole book open, it can be weird. Okay, let me split screen. And boom, I have a request for number 8. Let's throw that one up here. Another screen. Weird talking through a mask all day. Like my throat gets really dry, but if I cough, people think I have the Rana, which is not good either. Don't do Corona. Yeah, Nick.
So by all, you mean like, we should do 9, 10, 11, and 12?
Yeah, it's 9 through 12.
Alright.
Yep, that's what it means. A lot of times we'll say odds or evens, and if I really want to confuse my upperclassmen, I say EOO, which is every other odd, which means they have to do math to figure out the math that they have to do, which is very meta and kind of fun. Okay, looking at number 8, and you can as well. Jim's weekly pay is 2/3 of Alicia. I'm going to want to throw that up here so you can have a visual. Then the recording has it, and I'm doing it for the Vine. That's dating me. Jim's weekly pay is 2/3 of Alicia. Together they earn $600 per week. I am going to let A equal Alicia's pay. And we will let 2/3 of A equal Jim's pay. That's it. A plus 2/3 A equal to 600. I know I can add 1 plus 2/3, but it's so much more fun to multiply through by 3. 5A is equal to 1800, and A is, 360? Sweet. And that gives you both of them. How are you guys doing? What questions did you have on this? It's kind of a, feel free to throw them out. If you're at home, just shout them out, because you're still very, very small over there. Just be careful, because if Jim is, if you have J, then this is going to be 3/2 J for the other one, which you can do. Okay, so the standard we're going to have is that after we talk about a homework assignment, to upload it, I'm going to give you guys a solid hour, but I don't want it uploaded long after that. They have to do that because if I say, you can just do it the next day, you're going to forget about it. We don't have time for a little mini quiz right now. I know that shocks you. You're like so sad because it's like the end of the day. Cry me a river. But I do want you, if you have time right now, to upload your assignment. So then that's done and off your to-do list. So please take a minute to upload it. Make sure you're caught up on all the uploads. You should have assignments down there from the last couple days, and actually just this and getting to know you. Yep.
What page is the homework on for the textbook?
It is on 52.
I know the textbook usually has the odds, but are they even answers when you said like?
They are. So right underneath this tab in OneNote is a section that says key. So anytime there need to be evens, we type them up for you. Thank you for asking that, because part of this is checking your answers. I know I said at some point I wanted you to learn how to annotate, and we're building up to the point of where when we go over problems in class, I want you to do it on a separate color or some sort of separate ink to show what we did. I'm not going to count you off for that. But annotating means also anytime you get help on a question, citing a source on it, so you're not copying, you're annotating. Yep.
Nice.
This. So the better question is, when you guys leave class, you know where to find it.
Do we get a printed out version?
You don't, because it's textbook.
Oh.
We just copy the questions onto like a piece of paper and answer them.
When you do a word problem, don't copy the question down. Just put critical information, but don't copy a word problem down. Please save your time. No, but I do want to make sure you all on your phones or whatever know where to go to check homework. You have to be thinking cross-reference with the calendar. This was the lesson from today, so the homework would be right here. And then anytime we didn't get to something or do something like an exit quiz, I'm just going to delete that tab from here so that this is a record of what we actually did in the class. And then next year I can say like, oh, I didn't do the quiz. Yep.
What's the difference in like the content library between like page 4?
Period 4, period 5. And that answers that. The number 8 I just went over was on the previous assignment. So that was the one that we did yesterday, or whatever yesterday was. You'll get in the rhythm, I promise. It's going to take a little bit of time, and then you'll just be automatic. Okay. They usually start the exam at 3:10 these days. These last couple of days they did. If not, you guys are free to start your homework. Like, that's good time. Everyone online, you guys are free to go. Just start homework and kick in. Sure, see you, Nigel.